Okay, so we're talking about the difference between continuous graphs and discrete graphs. A continuous graph is a graph with connected lines or curves, so the keyword there is that it's connected, and a discrete graph is a graph with only distinct points. So the keyword there is that it's just points. Okay, on example 1, it says a math teacher tutors and charges $75 per hour. Because of the number of students she tutors, she can only work whole hours. The function f of x equals 35x relates the total amount made after x hours of tutoring. The teacher plans on tutoring between 3 and 8 hours a week. So is this situation discrete or continuous? And then there's several other questions that we would want to answer there. But first what we're going to do is make a graph. So we come to our calculator. We go to y equals, and we put the function y equals 35x in. And then we go to the table. And I know that I don't have to worry about negatives because I can't tutor negative hours. It says that the least number of hours she's going to tutor is 3, so I can see here that at 3 hours she will have made $105. I'm going to come over here and graph that ordered pair, 3, 105, which would be about right there. Okay. Then the next one is 4, 140, so I'm going to graph that next. So 4, 140 would be right there. Then the next one I have is 5, 175. So 5, 175 would be about right there. And then 6 would be at 210. So 6, 210. And then the next one I have is 7, 245. So 7, 245. And then the last one I know is 8, 280. And I know to stop there because I know that it said that she was going to work between 3 and 8 hours. So I know not to go beyond 8 hours because I know that she won't work any more than that. So then I have to decide if it's going to be discrete or continuous. Okay, discrete would be just leaving it like this, just leaving it with the dots. Continuous would be to take a line and connect the dots. Okay, by connecting the dots, you are insinuating that the values in between are acceptable. So here, if I connect them, then I'm insinuating that the numbers between 3 and 4 are acceptable values for this situation. But if you look back up here in the word problem, it says right here, she can only work whole hours. So if she can only work whole hours, she's only working these whole number of values. And because of that, we need to take the line off of there. So do not connect your points. Okay, 3 and 4 are okay, but the numbers between 3 and 4, like 3.5, are not acceptable values here because she can only work whole numbers. So to answer this question, we would say that this is a discrete situation, and the reason is because she can only work whole hours. Okay, and then the next question is, what is a reasonable domain? So here, because we had just those specific values, we're only going to list those specific numbers. So domain is x, so on our x's we went 3, 4, 5, 6, 7, and 8. So here in my domain, I'm going to make a list with the brackets. 3, 4, 5, 6, 7, 8. And then with the range, I'm going to list y values. So I'm going to look at the numbers going up this way. So the first one we had there was 105. And then it was 140. And then 175. And then 210. And then 245. and then 280. So those would be the range values. So if it's only specific points, you're just going to make a list of those specific points when it asks you to list the domain and the range. Then it says, let's see, I need to move this down a little bit. Oops. Let me move my graph. Then it says, what does the ordered pair 270 mean? So if I look over here at my calculator, I can see the ordered pair 270, so that would represent that for working 2 hours, she earned $70. So that answers my first question. So 270 means that for working 2 hours, she will get paid $70. But we should be able to know that 270 is not reasonable for the situation because she's going to work a minimum of 3 hours. So to answer this one where it says, is it reasonable, we would say, it is not reasonable because she excuse me, she will work at least 3 hours. Okay, then for example 2, it says a car can travel 30 miles on a gallon of gas and has a 20-gallon gas tank. Let G be the number of gallons of gas the car has in its tank. The function rule D equals 30G gives the distance D in miles that the car travels on G gallons. If the car goes between 300 and 480 miles, what is a reasonable amount of gas? So we'll start with our graph, and to make our graph, we need to go to the calculator and type our function in. So our function is y equals 30x, and then we go to the table. And I know I can see from right here, get out of the way, that she's traveling between 300 and 480 miles. Miles is a measure of the distance, and D is our distance, which is acting as the y value. So I know that I need to look for 300 and 480 in the y column. So I'm going to come over here to where I find 300. So I'm going to scroll down some. And when y is 300, x is 10, and I can see all the way here to 480 when x is 16, okay? So I'm going to graph these points. The first one is going to be 10, 300. Oh, I'm sorry, I think I got that one in the wrong spot. It should be right there. 10, 300. Okay, then the next one should be 11, 330. And then 12, 360. And then 13, 390. And then 14, 420. And then 15, 450. And then 16, 480. So on this one, we once again need to decide, should we connect the dots or just leave them alone? So if I connect them, I'm saying that the values between 10 and 11 are okay. So are the values for gallons of gas between 10 and 11 okay? And in this case, the answer is yes. It is okay to have 10.5 gallons of gas. So in this case, we would go ahead and connect our dots to look like that. So because we connected them and said that those numbers in between the dots are okay, That makes this a continuous graph. And the reason is that it is okay to have half gallons. Okay, so for our domain, remember domain is our x values. The smallest x value that we plotted was a 10. The largest x value that we plotted was 16. But because we do want to go ahead and include those decimals in between 10 and 16, we have to write it a little bit differently. We're not going to write it as a list. We're going to write it as a between statement. So we're going to say that our x values are between 10 and 16. And then for the range, ranges are your y values. So the smallest y value that was on our graph was 300. The largest y value on our graph was 480. So I will say my y values are between 300 and 480. And then it says, what does the ordered pair for 130 mean? And is it reasonable? So for 130 would mean for traveling, or excuse me, for using 4 gallons of gas, you would travel 130 miles. So I'm going to look over here and make sure that that point is in my table. So I'm going to go to 4. And I can look and see it should be 120. So that point's not even on the table, which means that it doesn't even fit the function. So to answer my question, is it reasonable? I would say it is not reasonable because it does not fit the function. Okay, and then on the next one, example 3, it says Maria is selling 4 tickets to the play she is in for $2.50 each. Write a function rule to describe how much money Maria can collect from selling tickets. Well, I know she's selling tickets for $2.50 each. Now, this 4 tickets actually has nothing to do with the function itself. It's the value that we're going to be substituting into the function. So the function itself is going to be f of x equals 250x. Okay, that's the function. So I'm going to take that function and I'm going to put it in my calculator. So y equals, and then I'm going to come here and I'm going to put 250x. And then I'm going to go to my calculator, and I know that she can sell 4 tickets. But I guess she doesn't have to sell all 4 tickets. She could sell just 3 of them, or 2 of them, or 1 of them, or even 0 of them. I know that she can't sell negative tickets, so I don't have to worry about that. And I know that since she only has 4 tickets, she's not going to go ahead and sell the 5th. So she's going to sell anywhere from 0 to 4 tickets. So my first order pair would be 0, 0. So on my graph, I'm going to plot 0, 0. Then for selling 1 ticket, she will have made $2.50. For 2 tickets, she will have made $5. For 3 tickets, she will have made $7.50. For 4 tickets, she will have made $10. And then I can stop there because I know that she's not going to sell more than 4 tickets. For this one, it would be a discrete graph. I would not be able to sell a half ticket, so the number between 0 and 1 would not be connected. They would not be included in this situation. So here it is a discrete situation, and the reason is you can't sell half a ticket. Okay? Now, it says, what is a reasonable domain? Because it's discrete, we cannot make the between statement. We have to go through and list the specific numbers. So for our domain, we used 0, 1, 2, 3, and 4. So I just make a list of those values. And then in a range, I'm going to look for my y's. So my y's were 0, 250, 5, 750, and 10. So then the question says, would 3.5, or what does the ordered pair 3.5, 8.75 mean? And would it be reasonable? Move that out of the way. 3.5, 8.75 would mean for selling 3.5 tickets, she would earn $8.75, which is not reasonable, so it would not be reasonable because it's not possible to sell half a ticket. Okay, and then the homework for tonight. Oh, by the way, we didn't do example 4 in any of the classes. We just didn't get to it, but you can do it if you want to, not required. The homework for tonight was a worksheet, and you do need graph paper for it. So if you don't have any, see me and I can get you some, and hope to get you caught up soon.